I'm going to try and explain how we want the alignment to be for these manifolds that we make here at Wolf Aircraft. Um, there's a way that the icon is holding the alignment for the part, and we'd like to see if we can do something a little bit different than what we're doing. What I've got here, this green area, is the sheath tolerance. I've got two tubes that are drawn to the exact same dimensions, and these dimensions came off of an actual part that we bent. And the way our alignment is set up is we have our alignment is from bend point 2, or I'm sorry, our alignment is from straight end 1 to bend point 2, and also using straight start 4. And that is a point line plane alignment. So for me to duplicate that alignment in here, what I need to do is I need to set up constraints, which is constraining this cylinder to this cylinder here. And then I need to constrain this tangent point to that tangent. That gives me the constraint for the straight end 1 and the bend point 2. So that's holding that cylinder and that tangent in place. And then what the icon does, when it does the third point, the straight end 4, it will take and constrain the tangent point to the plane of tangency as far as I can figure. Now I have a screenshot here that shows the results from inspection of this tube, and you can see here in the Y direction that we are only 1/1000ths off, and that's where I'm getting the idea that the when the alignment is generated, that it's trying to hold it to that point of tangency. What we would like to see, and you can see the same duplication here as far as what that tube looks like. What we would like to see, I'm going to turn this tube off and we'll work with this tube now. What I would like to see is an alignment that holds this cylinder to this cylinder with no constraint on the distance that it flows within there. And then I would like to see a constraint of the point of tangency to the sheath cylinder, and allow that to set the distance in what would be the Z direction, and constrain the tangent to the center line to check the distance. And then you can see that the tolerance in this area, you can see where the part falls a little bit out of tolerance in this area right here. But this cylinder is very close to matching the sheath cylinder. And this is the important area for this series of parts, and there's probably 30 part numbers that we do like this, that this cylinder is held at a 0 tolerance, and this cylinder is held within a sheath tolerance of 20/1000ths. So this is the inspection that we would like to create, and we're hoping that you guys can help us with it. Thank you.